I apologize for the narrow presentation. I did not learn until just yesterday from Godwin that with a one click, you can make PowerPoint 16 by 9. So sorry for the wasted black space. Today's discussion is an update on the SwissMicros DM41X. And I say update because last year at the 19 HPCC conference, we previewed it. The subtitle here, a little late, a lot better, is reference to one of the few but hard-sought advantages of the pandemic. The 41X was originally planned to be released production in Q1 of 2020, but the pandemic happened and that changed so much of what we know. But the upside is it provided more time before release for some enhancements and improvements, and that's primarily what I'm going to talk about today. The core functionality and features I covered in last year's video. If you haven't had a chance to see that yet or you don't have one, that would fill some of that in. So I'm not trying to skip some basics. I just don't want to waste time going through them again. First of all, the DM41X it's a 41CX clone with a lot of modern enhancements enabled by the hardware and DMCP platform that SwissMicros created for initially the DM42. And most people here are familiar with that and probably also have one. The key difference, of course, is that this is a 41, not a 42, but it is a pure 41, and we'll talk about that in a moment. It runs all 41 software, focal software, user code, also all synthetics and M code. It also runs essentially all of the ROMs that are out there. It's fast. In fast mode, it clocks anywhere between 40 to 55 times a normal CX, so in the same class as Turbo 50 in the CL. But it also has one times if you have code or applications or things that you're using that require the original speed or you're benchmarking or something, that's also available. One of the key features and the breakthrough feature in many ways is it's easy to share information from your PC to your 41X or vice versa, despite the enhancements that the pillbox brought to the 41 and others to make it dramatically easier to use with the HPIL. It's still difficult to do easy file transfers because of formats and conversions and so forth. So the USB connectivity has dramatically changed that. And the reference to better, as I'll get to in the various subsequent slides and discussion, there have been quite a few enhancements, both of features we talked about then, but also completely new features. But probably the biggest news, if you're not aware, is that the 41X is available and you can buy it now. It's available at the SwissMicros site. And ship times seem to vary between three to 4 days in Europe and a maximum of about 12 days in US. I don't know about to other countries on the far side of the world, but you can kind of extrapolate from there. I grouped the things we talked about into the core design focus and objectives that we had for the 41X. And those are in priority order, I guess I would say. Number one, to be completely 100% compatible with all 41X behavior in an enhanced way, but fully compatible. And that's due to the enormous amount of materials, software, programs, modules, books, tools, etc. out there. Probably more materials in the ecosystem for the 41 than any other calculator that's ever been produced. The most notable change when you look at the device, of course, is the huge screen compared to the one-line display that the 41 had. And we've used that in some ways, extending the same display format with more versions of the lines, and other ways, new UI to use the screen real estate. The single largest difference, in my opinion, other than the obvious screen, is it's dramatically easier to install and use the modules than other platforms out there now. If you've used the CL and Novi and Clonix and some of the other hardware devices, you have to have a reasonable amount of skill and patience to use them. And though they do work and work fine, they're not something that you just casually plug in to check out, which is what a lot of users want to do. Hey, I always wanted to use the blah, blah, blah module and just pop it in. Ideally mirroring the simplicity of the hardware, the original hardware, just plug it in and see what it does. The next category is to create usability enhancements for things that are being done all the time or things that are tedious to do, spelling out long function names and things of that nature. If you use a function name that's 7 letters long and you're using it 5 times a day, one thing you can do is assign the keys. So we kind of took a look at some of that. We'll talk about that in a moment. The last two are related. One is very simple file exchange with the PC. By simple, I mean just connect it, put it into communication mode, and proceed. You don't need special software that runs on a PC and a Mac and a Linux and this and that. It's simply using the MSC mode so that the device appears to be another drive on your computer. And also simple backup and restore, both of individual components in the system, but also for the full unit. And we'll talk about that in detail as well. Regarding compatibility, the ultimate compatibility test is the 41X is running the 41CX operating system completely through emulation. So it's literally running the same NFL code that the 41CXs have been running. Nothing in the OS code was changed. There were some new functions added to provide more functionality, but nothing was changed, nothing was patched. To my knowledge, there is no code that runs on a 41 that will not run on the 41X. And I eagerly would like to hear if someone finds something that violates that. As I mentioned, focal, synthetics, and M code, the normal way one would use them on a 41, are all supported. The device comes with the maximum RAM that the 41 supports, both normal user RAM and also extended memory. All of the pages are used the same way they were used in a 41. There's no tricks or special mapping or anything. One thing that's different is upper pages, not different from a 41, but different from some of these other device options, is the upper pages in upper meaning 8 through F can be configured as QROM or quasi-ROM, which is a term that was coined in the 80s, which is putting RAM into the ROM address space so that you can have volatile memory that can be changed for writing code or modifying modules or storing programs and so forth. RAM in the 41 device is mapped into that ROM space, so you can use it the way an MLDL or similar device was used in the past. Things like the RAM box, the heat packs, and others that were using this upper RAM space can take advantage of them the exact same way that they were done back then. All modules, all known modules, are supported with the obvious exception of modules that were associated with devices that are not physically supported. There are no ports, and HPIL is not supported. So things like the wand, the original strip printer, the card reader, and HPIL are not supported because they're physically not supported. One slight exception to that is the actual printer module from the 82143 is installed in the device, and that is used for printing to the IR via IR. So it's a hybrid. It's the original strip printer ROM, but the output is through IR. 20 of the most commonly used HP ROMs are installed. And when I say commonly used, some of the more obscure things like the diagnostics and the development code, the Devil ROM, and things of that nature that just don't generally apply are not in there, though they can be installed because some of them have non-communication related features. And also the PPC ROM, essentially because these are all benign and safe to use amongst people, folks that don't even know what they're doing with them. You can plug them in and use them. The PPC ROM can get you in trouble quickly if you don't know what you're doing, if you start moving the curtain and other things. The other ROMs, both in some that we'll talk about in a moment, are available in various places. A collection of Angel Martin's ROMs are all available on the SwissMicros website. And those are not included because the idea we've taken is that some of those are extended functionality. You really need to understand what you're doing with them and how. So there's a bit of a burden to learn what you're doing with them to then install them and use them. But they all work fine and supported and so forth. And also the hp41.org website and others have collections of mod files broadly, and Sylvain will talk about this later, but broadly, the modules of old that you find come in two formats today: a mod file, which a mod represents a full module, and ROM files, which represent individual pages. The 41CL, which in recent years Monty has done a lot of work with Sylvain's help to create a collection of all of the known modules, are all in ROM format. Sylvain's going to talk about a possibility in the future of a way to make those accessible. There are tools available that make it relatively easy to convert a ROM format file into a mod format file, but you have to know a little bit about what you're doing. And I expect what will happen is as users have interest in particular modules, they'll explore those, take them, turn them into mod files, and start sharing them. And we're going to think about a place that these can be collected for universal access. The modules are added to the device by simply copying a file over to the 41X. And I'm going to go through detail of the steps to copy it and the user interface for doing it. It's more interesting and easier to understand how simple it is with a live demonstration, but with the remote camera and so forth, it's just not viable to do it that way. You can store lots and lots of ROMs. There's 512K of flash space, so you can store more ROMs than you would ever want to use. It's still far less than a 41CL can hold. A 41CL can hold 512 and now 1024 ROMs, so there's far more there. But realistically, no person would ever need to have that many involved at one time. I dare say you could never put more in. There's always enough room for all the ones that you would want at any given time. And again, the 41X will hold 512K of modules that are not in use. The limit of how many in use is going to be driven by the architecture of the 41 and the pages available. There are utilities, as I mentioned, for converting ROM files. And there's actual work going on now by several people for doing that. MLDL2K from Minder Coopers is in development now. That one's well known amongst people that have done this stuff. And there's work going on with that. One of the interesting and exciting things about the 41X is it provides full support for what I call all the exotics, the things that none of us had or could afford or didn't get around to playing with back in the day. Things like heat packs, the CCD-ROM, Zen-ROM, Z-PROM, and more modern Angel's Library 4 and all of the enhanced functionality, modern, truly amazing modules that Angel's put together that if you haven't looked into these, you should, because There's modules there for doing just about everything, including some hybrids. The CCD had a lot of interesting features, and there are a lot of features in different modules. Angels created a module called OSX that has taken it's what I kind of consider some of the most interesting features from various different modules and combined them into one general purpose utility module that no 41 that I own is without at any given moment. And most people that explore it and understand what it is have the same conclusion. Okay, that's just got to be there. Moving on to the screen, we covered this in a lot of detail last time, but I will talk about here. For general, the calculator screen view, there are 3 different views of the calculator functions. This view here is showing the X, Y, Z, and T stack. This view and this view, and I think you can see my cursor here. Not if you can see the cursor, because I can't. Can people see it? No, you can't see the cursor. Okay, sorry about that. So then the top one on the right is the 4 stack view. The next one down is called the system information X and alpha. The upper 3 lines are system information that I covered last time, status of the program, names, and so forth. I won't spend a lot of time on that today. And the 2 large lines are the X register and the alpha register. And the reason for showing alpha and X is in many cases, application packs use alpha for prompts for data. But once you start entering the data, the prompts are lost. So what can easily happen is you can start entering an interest rate and then forget which button the interest button is entered on. So this retains the alpha display while you're doing entry. And that's interesting and very useful in those modes. But it can also be, as feedback has shown, to be annoying and distracting in other uses. So one of the reactions to feedback during the beta phase was to institute the bottom one on the right, which is X and Y, in addition to the system information. So you don't have the alpha data possibly distracting and interfering with use. Also, the multi-line editor, which is the standard program mode that the 41X uses. Last year when we looked at it, we had 1-line view and 4-line views, as you can see in the 2 bottom. So the bottom left is showing you program view in what we call 1-line view. You can just hit the display button and toggle into 4-line, but that's been enhanced to 6-line and 8-line, depending on the trade-off of readability and visibility within the code to understand. Most people I talk to, probably all aging like me, find the 6-line mode to be the most sort of the optimum trade-off between the two, but this totally depends on what you're trying to see. But you could just hit the display mode, even in the middle of entering instructions, you can hit the display mode to change view. So if you're doing a go-to and you forget what it is, it's a few lines above, you can go to 8-line view to see what it is, what have you. You can just toggle back and forth whenever you like. Other things that have been done that take advantage of the larger LCD, and they're not all here, but I picked a couple different ones to show it, is the display of the flag status. Earlier versions of this were showing fewer flags per screen and multiple screens, and that became tedious because you just kind of want to pop it on. Basically, at any given moment, you're usually looking just to see the one flag you have in question, so you don't want to go to the flag screen and have to page down or something to find the one you want. So this is a layout David came up with that uses the full width and size of the screen to get all of them on there at one time. But one of the most useful and interesting applications of the of the large screen is the built-in help, which is similar to the DM42, but was enhanced in the 41X. And the same enhancement was actually released this morning on a new version of software for the DM42. which adds multiple file support. So on the lower left, you can see the idea of links. You can highlight with the cursor keys another subject, and that's a link that will take you further down the page. So if you click on the external references, it brings you to that section. But the key change is the addition of handling multiple help files that can link back and forth seamlessly between the various files. You can also hit a button and open up any file that's in there. But for example, a few months back, Angel created a module, and then the help content was extracted from that module for just reference information for 41 use, this generic 41, but it also had some things like some features for the Warp core. So this is the second file that's added, and you can just modify the original help file to include a link, which is a tag, just like it is in HTML. I'm sorry, I skipped that. The browser, the help system is really just a lightweight browser with limited tag support, but you use it just like you do to navigate a web page. So you click on a link and it opens that portion of the file you're in or a new file, and you can chain amongst different files. The idea being that you can create a help file for each module or your own programs or whatever you like. So as you want to share a module, for example, some of the stuff that Angel has done, he's talked about possibly creating help files for each of his modules, which is a lot of work. But if you're familiar with his modules, there are amazingly beautiful and complete manuals for each one. You don't need the full manual online, but you may need reference information for the arguments to a function or exactly what setting is needed or something of that nature. So the idea is to have your own help files that you add for each module or application that you want. Also, there's documentation describing each of the available tags that can be used for creating things like links and special characters and things of that nature. And that documentation is available to download and look at, but it's also actually available online. There's actual help file of the help supported tags and content provided on the device. So you can look that up. So it's an example built in itself, so to speak, to explain some of these features and how to use them. Going to move on to the installation and management of ROM modules. The prime motivation for a different approach here was there are several different devices currently available that support loading all these modules. The 41CL, the Clonix and Novi, for those lucky enough to have gotten an MLDL2K, old Rambox devices, and actual even older MLDL devices are available, but they take a fairly significant investment of time and skills to learn to use them. They work reliably and they work fine, but they're not simple to use, and the barrier of learning to use them has prevented a lot of people from effectively doing that. I know I've talked to many 41CL users who have it and love it, but don't use it because it's complicated to remember how to change modules and select different ones and things of that nature. And if it's not something you're doing all the time, then indeed it is something that you need to look up and find a manual and remember what the commands are and so forth. And the Clonix Novi have similar barriers that actually are quite simple to use, but it appears to be quite technical and somewhat daunting to a lot of users. So we were trying to focus on something that has the simplicity of an emulator where you're literally just clicking on a file and poof, it's plugged in, and have that simplicity available on a real device. So after a lot of time, that has turned into the three-step, what I call the three-step procedure, where you simply copy a mod file from the PC to the 41X, and again, that's done via USB. I'll talk about in a moment. The next stage is to import that into the flash storage in the device The ROMs are stored there. Again, more ROMs. Think of those as offline ROMs that are in the device. They're there and ready to plug in, but not online until you do plug them in. And the third step is the process of actually plugging them in so that they're available for the 41 user to use. And so this is an attempt to describe that process without the visuals of a live demo, which makes it simpler and easier. But it is simple enough that hopefully this can convey it. The first step is to connect the PC. And what one does is there's commands in the menu to go to the USB mode. And when you do that, you connect to a PC or Mac or Linux. It uses what's called MSC mode that you've all become familiar to when you plug in a USB drive. You plug it in and then poof, the E drive or F drive or whatever appears on your machine, and you can then see all of the files available on the device. In the case of the 41X, you would see initially, not all, but up to this set of 9 folders here. Initially, the device comes, some of these folders are not there. If you've not copied any information to the device yet, or you've not used some of the features, then the folders may not be there. But the 41X will recognize if it needs them, they're not there, and create them automatically for you. So if you don't see them and you want to use a feature, don't worry, you don't have to go create folders yourself. It will just do that for you. But once you've used all the features, all 9 of these folders are there. And the top there where I'm showing you, the PC view of the structure is that if you were to click on the mods folder on the PC, you would see a traditional listing of files the way you see it on your PC or in the Finder and Mac and so forth. Alternately, on the 41X, the view of that folder from the Manage Modules screen is seen in the upper right. So that is the device view of that folder. But you can see it's analogous. There's navigation to go to the parent folder and scroll down the screens. And there are buttons that let you scroll to the top of the list and the bottom of the list and change from the left to the right to make navigation of the larger set of modules or files in a given folder easier. This particular screen is accessed from the second screen down. You'll see the Manage Modules and Flash screen. The bottom left button is Import. So in step 1, you copy the mod files that you want to use into this folder. Once they're copied, you can disconnect from the PC if you'd like. You can leave it connected to power the device while you're doing this. That's fine too. But the device has to be taken, obviously, out of that USB mode to do the other functions. Then the next step, going back to here, step 1 was copy the file. Step 2 was move it to Flash. So that's importing from the FAT drive to the flash drive is done in the Manage Modules in Flash screen. When you go to that screen, initially there's nothing in Flash. So you push the import button, the F1, the top left button, and it opens up what you now see is the top right screen. It gives you a list of those files that you've copied over. You just move the cursor to the one you want to import, press enter, and it brings you back to the Manage Modules and Flash screen. And then you can repeat that to copy as many mod files into Flash as you'd like. Again, there's 512K of Flash, but there's no reason to copy more than the ones that you're likely to switch between. At the bottom of that screen, you'll see other buttons there: Mod, ROMs, Flash Delete, Clear Flash. Successfully, those mod for a given one, if you highlight it, it will show you the metadata in the module file. For example, things like the name that you see on this screen, but also things that are related to the definition of a mod file. The ROMs button shows you individual details about each of the ROMs. And for those that aren't familiar and wondering, a module file can contain more than one ROM. One ROM is 4K. Some of HP's application modules literally needed more than one ROM just to fit the code in. So there's multiple ROMs, but there are also third-party modules that take ROMs from different places with different functionality. So a module can contain multiple ROMs. Each ROM has its own properties, and these buttons bring you to views that let you see those. Flash lets you see the status of how much of your flash you've used and how much is available. Delete lets you remove the highlighted item in here from the flash area. If you've installed a module and you checked it out and decide, no, it's not what I thought, I don't really want that, or perhaps you want to put an updated version in, the delete lets you remove individual items from flash. Clear flash is obvious. It lets you just wipe the flash area of the module so you can start again. So that's step 2. Again, number 1, we copied it to the device. Number 2, we've now moved them into flash. So now what's left, step 3, is to plug the modules in. That's done from the active modules screen, where you can see those modules that you have selected. In the active module screen, when you first come, it's empty. Again, the bottom left button, plug, brings you back to the list in the Manage Modules and Flash screen to select one to plug in. And we select it and plug it in. It then comes back to the active module screen. You'll see the top line is highlighted. When you click the plug button and select one, the module that you select will be installed below the highlighted one. And that's relevant because you see the bottom bullet here in the chart. When you go to install, at the end of selecting the modules, you click enter to leave the screen. The loader then proceeds to load the modules that you've selected in a top-down fashion. So in the 41, you could plug a module into port 1 or port 2 and so forth. So you had some control over the sequence by that. In the case of the 41X, you control that sequence in the order in which you specify the modules top down. In some cases, in my example, the top one, and it happens to be the second one, the modules themselves know that they can only be installed into particular pages in the 41 structure. So even if I put those at the end of this list, they would still be plugged into pages 4 and 7 respectively. But I'm just OCD, so because they go into lower ports, I put them at the top of the list. So the idea here is, if once you plug modules in some cases, it quite literally doesn't matter what order they're in. If you're just going to plug in the math ROM and surveying ROM and statistics ROM pack, it doesn't matter what order they're in. There's enough address space for them to go, and the sequence that they appear doesn't matter. The only apparent difference would be the order that you'd see them in Cat2. But for some other applications, it does make a difference. HPACS is one. Some others need to have precedence in terms of lower ports or lower pages, things of that nature. So this lets you control it. You'll see at the bottom of the active module screen, there are buttons for move up and move down. The idea is, if you want to change the sort order for something that's already in the list, you just highlight it and then move it up and down the list to change the order that they would be presented to the loader when you proceed to finish from here. But one of the most interesting new features is something that has been lacking all along, largely due to the limited display. But the question is, what module is where? How can I tell what's plugged in, what's going on? So this screen, the ROM map, was introduced to do that. And at the beginning, it looks very busy because there's a lot of information there that many users aren't even aware is going on. And the primary thing in that area is 41 can have code in multiple banks. Most people are familiar with bank switching, but the idea is different sets of code can take the same logical address with just a master bit, essentially saying, I'm going to use bank 1, and then all that 4K is available, but then it switches to bank 2, and then essentially 4K more code is available without taking up more linear address space. In the early modules from HP, there were initially only one bank. Things like the Advantage ROM and others came out adding a second bank, and eventually that was expanded out to 4 banks. So not surprisingly, things like some of Angel's most interesting modern ROMs are using the full 4 banks for doing that. So that's what it's showing you with the 4 banks across the screen. The P down the left is the page. So you'll see that there are 2 screens to see all of it, pages 0 through 7 and pages 8 through F. And many modules only use bank 1, and that's not surprising because they're either vintage or there are other limitations on there. And the coding of what is there is described in the chart. M4-0 means that it's something that is in module number 4 in the 0th bank, the bottom bank. Also, the right column can be toggled by the button under it. In the top 2 screens, that is showing you the module by page. So as you look down into, if I look at page A, I can see that the 5th module is in bank 0, 1, and 2, but to the right, it's showing me that that module is the warp core module. The button on the bottom right lets you toggle the view to see, well, wait a minute, what are the other modules? And so it just lets you see a list of the modules installed, 1 through 6 in this case, but it also, you can toggle back to see for each page what is in there. You might notice that the bank numbering in the operating system is different from the others, and that's just the way it is because there are no banks in the operating system code, but there are really 5 components to it. You see the 0, 1, 2, 3, 4, 5 in those. The others are all driven by the bank. So very, very handy screen to understand what module is where and how to do it. Moreover, if you see something here that isn't what you desire in terms of the sequence, then what do you have to do? You have to go back to the active module screen and use those buttons I talked about to shift the order. We've added a button right here in the screen. You see at the bottom center, which is to the active module screen, which will bring you to that view, let you make changes. And when you exit that view, you come back here. So it lets you very quickly just bounce back and forth between the 2 screens to see what is loading where. If you don't like it, you go to the active module screen, move the module up and down or whatever to change the order, and then come back here until you see things are structured in the right pages as you want them to be. Also, if you look in the bottom screen, the top 2 lines, these 2 are the RAM pages allocated by the HPACS module. This is the HPACS 4H module that Angel modified that lets you allocate a standard HPACS, which is 2 4K pages. So you'll see in that case in the bank listing that it's followed by R as a reminder that those are RAM pages, not ROM pages. Probably harder to explain than it is to use and see in person. Once you see it and get used to it, it's very intuitive and very simple. But this view is what all of these machines have wanted to see all along. One of the hardest things to determine on a 41 is what is logically plugged in where, which can be different from what is physically plugged in where. And this gives you insight into that entire process. In the area of usability, there are 19 additional functions that were added. Angel selected some general purpose, general utility functions. I'm not going to go into them in detail. They're all in the manual, but in the broad areas of system control, alpha enhancements, and extended memory functions. Things like change the name of an extended memory file. You don't. That's something that traditionally you can't do. get the leftmost character in alpha instead of the rightmost, and things of that nature. Also, add-dollar is an enhanced version of the add text editor that at last provides access to all the lowercase letters and all the special characters. So for the very patient, full ASCII file editing and so forth. Also, because the keyboard layout is different on the 41X, all of the special keyboard commands that Ed uses are available, and those are visible on the silk screen. Well, it's not silk screen, actually the laser engraved image on the back of the 41X. And I should have put a photo of that in, and I didn't. So when we're done, I will hold one. Maybe Godwin hold one up to the, well, everyone's looking at this. Never mind. We'll hold it up to the screen later. One of the more interesting and more useful functions added in the 41X in the past few months is the feature called custom commands. That is, you can think of it as a macro feature. You can think of it as a second shift capability. There are different ways to view it. But the idea is another way to make accessing frequently used and complex commands easier from the keyboard. If you look at the screen on the right, the top screen, you can see the A through P and the 1 through 6. The idea is these are arguments to the custom key. So you click you push the custom key and then push A in this example, because as I've set it up, that's equivalent to doing execute ALENG, which is something like nine keystrokes or something. So it shortens it from the however many that is with the alpha and spelling it out to the simple 2 keystrokes. You just custom A does that. Custom B does the block FCAT, PageCat, Hepter, and so forth. So it's a little bit like the user assigned keyboard, except it doesn't interfere with the regular keyboard commands. So it gives you a way to retain the existing default plus keyboard assignments that you've used, another way to access the same, not the same, but in this up to, what is it, 19 different keys for commands that all come down to two keystrokes rather. You can see the left column has, those are system functions that are frequently accessed. Depending on what you do, these may or may not be the things that you access most frequently, but they're things that across general use, these are things that are accessed most often. The 1 through 6 cannot be redefined, but the A through P can be redefined. And the way one defines those is in the bottom screen on the keyboard. If you hit Shift Custom, the Shift Custom brings you into the configure screen seen at the bottom, and that's an editor of the above commands essentially. So if I wanted to change what I use for the E command, I would go to the bottom screen, I just press E, it opens an edit in that command, I hit backspace and get rid of $, and put in whatever command I want there. And there's no requirement for them to correspond letter-wise, but it's obviously a mnemonic, and that helps with remembering what's where for doing that. Like, for example, I use the size command on I because I couldn't think of anything I need to use that isn't readily available, and size sounds like I, so I put it there. There's nothing special or magic about these. These are just examples to illustrate how one can use it. In addition to the A through P, 3 other keys are also available for assignment, and that's the alpha key, the up and the down arrows, which in my case I've assigned to PAC because that's probably the command I use most often, and Shift Alpha is just simpler than other assignments. I also put fast on the shift up and slow on the shift down to make those available when we're testing. We're testing in fast mode and slow mode. But you can put anything you want there, just whatever happens to correspond for your convenience. Also, you see in the bottom 1 load and 2 save. Like most of the special features in here, one can save their settings to a file, so you can have multiple sets. So you can save a set for when you're doing this or that, and then create another set of macros for doing some other function. So maybe while you're doing M code, you're going to have a bunch of frequently used commands assigned. So you would go into your, you would load up your M code developing set of assignments. But if you're doing financial calculations, most likely the M code ones aren't going to help you there. So you can have another set. So a repeated idea you're going to see through many features is the idea of a personality, the ability to save a set of data for that particular feature for that personality. Also, one advantage, or not advantage, but one side effect that comes from being able to save them is being able to share them. You can just save a set of keys, and somebody says, "Hey, that's handy. How do I do that?" You can just mail them the file, and they can put it in. Moving on, the PC data exchange. One of the common things to do is moving this data back and forth. Again, you just put it into the, connect the USB cable and put it into the FAT mode, and you get the new drive on the PC. There's no software needed. All of these supported OSs do this automatically. There's no setting or anything magic. One thing I will note, though, is that before you disconnect the 41X from your computer, you should tell the computer that you're going to disconnect it in the same way that you would tell the computer you're going to disconnect a thumb drive. You don't want to remove a thumb drive while you have a file open. Correspondingly, you don't want to remove the 41X while you have some active files in use, copying or something of that nature. And once it's connected, of course, you just drag files back and forth. All of the folders can be copied to or from the PC, but they don't all make sense. For example, the screens folder contains screen captures that I created by holding down the Shift key and pressing the DSP. It makes a full screen. For example, if you're making a PowerPoint deck like this one and you need screen images, more likely if what you're trying to do is create some documentation, or another reason, actually the primary reason we put it in, is for people to be able to capture a screen to report a bug or an issue that they're having. If you're seeing something strange on the screen, then just do Shift Display, and then the screens folder has a date time stamped file in PNG format that lets you then put that into the bug report. So instead of saying somewhere near the top on the left it's doing something weird, you just make a screenshot and report that. Also, similarly, the help and the off image folders in the 41X, there's no reason to be taking data out of those. That's simply data that you're putting in, the help files that you want to customize, and the off image images when you shut the machine off. On the other hand, the other folders, backup, keys, mods, prog, RAM, and state, are all things that you may want to be copying data into. You may want to be copying data out of, depending on what you're doing and if you're sharing data with other people. Clearly, things like the mods folder you want to be dragging stuff into. You may not want to be taking stuff out of there, but you can to share something. Programs are raw files that you've imported and or exported. You type a long program in, you share it, people say that's great. You can just do export to raw, copy that file, and then share it on a forum post or something of that nature. RAM holds the upper RAM. We talked about the QROM feature. That holds an image of the RAM that was saved last in the system. Again, from the modules menu, you can save all of the RAM data at any time and also load it back in. So that's one way for you to back up your data. Again, the same themes pervade through. It also lets you save the data. So, share the data. So you can populate the upper RAM with some information and then send that to someone else, and they can then have that data there. The state file contains all of the information within what the 41 knows of as its data. In other words, user programs, user registers, flags, settings, and those things things within the 41CX view. Many of these other things are not things that are within view of the 41CX. The key files that you've saved for the custom feature, raw files, upper RAM, backups, things of that nature, those are metadata around what the 41 knows. The state file is everything that the 41 knows about. And that's also useful because that, once that's exported, can be used to copy into a 41, the DM41 and the DM41L. They don't have these other features, but they can take the entire capability not capability, but the entire contents of a 41X. So one thing one can do, because there are, well, until a few hours from now, there aren't easy ways to get some things into one of those other 41s. You could arguably use a 41X to bring data in easier, put it into your 41, then save the state, and then take that state file and copy it to the DM41L or the DM41. Godwin's going to talk about some of that stuff a little later. Backup and restore, I've mentioned the two key reasons to do it is to both protect from an archiving and backup copy perspective, but also to share it. A good way to take one of these sets of things and send it to a friend. If there's somebody that doesn't really understand the process of how to load modules and some of that other stuff, you can save your module configuration and send it to the person. Things of that nature. Each one of the things listed in the middle, the custom keys, the upper RAM, the state, the raw files, the module configuration, each one of those has a similar operation and named load and save component. So you can load the file, and each one of these lets you name what you're saving, so you can have a whole library of individual state files or individual upper RAM files or custom key files. The idea being, again, you can establish or a library of application-specific personalities for each of these areas. But if you want to save your entire machine, it's cumbersome to save 5 different components and remember what the files are and remember what folders they are, etc. So the full backup is exactly what you think it is. It saves the entire contents of your machine and your configuration into one named area. So, for example, if you create different personalities on your 41X, and I picked 3 examples at the bottom. If you're going to be writing M code sometime, but then you want to switch to, I want to be doing some estimates for refinancing something or investment, and or a set of power calculations for EE types. The modules that you use, the key assignments that you use, the programs in RAM and registers that you use probably have nothing in common, and there's no need to try and get all of that into one configuration. You just end up with a mess. So the idea would be to create an entire configuration for your 41X, where you're going to have programs and modules and key assignments and all the other things associated with it. And then you do a full backup of that entire personality under one name. And subsequent to that, when you want to go back to that application use, you're just going to load up that one full backup, and it's going to restore all these different components into the 41X. So you're basically, it's almost like switching to a different 41 to have all that available, configured the way you want. All you have to do is select that one name. That is all, not surprisingly, stored in the backup folder. And there's a lot of flexibility in there. The manual does describe it. You can have folders in folders with other things and save all kinds of different things. So it's as simple as you want it to be, but it's as complex as you'd like it to be if you want to do some fancy things with saving. A few other things coming up on the time that I presumed would not have time to talk about, and I'm going to discuss them very quickly. The IR printer has a delay command that lets you tweak the interline delay to work with the printer. One interesting development, Minder Cooper has created using information earlier that Martin Hepperl had generated. You see the photo on the upper right. that little device that you see there is an IR printer receiver that HP sold back in the day with a dedicated cable to plug into the early HP LaserJet printers when people were walking around with calculators and palm tops and wizards and things of that nature that had IR printing capability. You would just put this IR receiver out next to a printer so you could walk up and squirt the information you want into the printer. Those modules are out on eBay and other places for pennies. I think I paid $8 or $9 for one of those. Martin figured out some of the underlying technical aspects of modifying that to use as a PC peripheral. Minder figured out a way to take, and I won't go into in detail, I put the links there, but a way to take a dedicated processor in that package. So that package that you see right there has been modified both to essentially to turn it into a USB peripheral. The idea here is Christoph Gisselinks has the awesome virtual IR printer application that can accept logical information from the virtual app emulators that he's done, but it can also be redirected to accept input from the outside world. So basically the idea is you take this device and connect it to the USB port, and so now with your 41X and 42, you can print to that application so that it's a way to instantly capture the output. Similar to if you use the Pillbox and the ILPer software, the output of the machines can be captured in the text window. This provides a similar capability. So while the 41X will not let you connect to a PC to send the output directly, you can use a device like this to capture the output in the print window to collect output there and then share it that way. And I put the links in for all the devices. There's also the ability to export and restore all of the lower level settings should you need to do that. Things like the printer time delay. Am I in SI-XY mode? Have I muted things? Things that are configuration for your current machine, like the date format for the header line, all of the, again, the metadata around it. There is a way to get all that and save that to restore later if you'd want to. There are other details as well. The manual is online. Everyone has seen probably that the website has been reorganized. Most of that is done. If you haven't seen what used to be available in various places, all the technical support information like firmware and manuals and things like that is available at, and I should have put a link here, but I didn't, is available at, help me out, technical.swissmicros.com, and you'll see a kind of a file explorer view. Basically, it's a web front end onto an FTP view of things. Support files are there. I want to spend some time giving thanks where they're due. First and foremost, of course, to Michael and David for creating SwissMicros and these awesome machines that we love. Both tremendously interesting and talented individuals, and a pleasure to work with in every way and every day. Tremendous patience shown on their part when I go on too long. Godwin and Angel for their direct involvement in the project. Again, ideas, testing, patience, an important ingredient in this. It doesn't always show, but patience is one of the key ingredients in a product like this. All the 41X beta customers, unlike other beta programs I've been involved in, there was some very good input very quickly. Obviously, bug reports, this isn't working, that isn't working, but also some really good ideas. And you've seen some of those features that came from ideas from the beta feedback made it into the product. And I encourage people to continue to submit ideas. Some may not get implemented, some may not be implemented quickly, but please send the ideas along. It's all, everyone uses these differently, and it's important. The communities like the one we're in now, I want to thank the HHC, HPCC, the Allschwill, the museum, and the SwissMicros forum communities for their tolerance of my rantings. Also the contributions and education by some really, really smart folks, and keeping this, what might be seen as a vintage hobby, new and interesting. But thanks especially, of course, to HPCC, to Lodek, Bruce, Mark, and others for making this possible, and a lot of work that's invisible to most people for getting this to together to come online. And that's all I have.